Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello and welcome to this week's episode of Better Buildings for Humans. I'm your host, Joe Menchefski. This is the podcast where we have conversations about the impact that the built environment has on our health, our wellness, our happiness, our comfort, our general joy of being alive, our productivity, and I always like to talk about sustainable design as well. Today we have our very first repeat guest, Ale Menchaca from AIRLIT Studios. Ale, it's wonderful to have you back.
It's so exciting to be back. I have become a fervent fan of the podcast, and so I am just very honored to be invited again.
Oh, it's great to have you back. We are going to geek out pretty hard today, but before we get into it, we're going to talk about TEDI. I want to make sure that for anybody who hasn't listened to your first episode, they have a little bit of an understanding of who you are. Tell
Yeah.
us the story. Tell me the story again about how an astronaut, an aspiring astronaut, became a world-renowned sustainability and human-centric design consultant.
Oh boy, talk about career change. I born and raised in Mexico, so dreaming to become Mexico's first female astronaut. I was like that as a kid. I was like that as a teenager. I was like that as an undergrad, and I got into MIT to do aerospace engineering. And so I was going to be the astronaut. And then I went through a little bit of a culture shock when moving to the US, where in Mexico we grew up preserving resources just as a matter of fact, water, paper, etc. And in moving to the US, I thought that was going to be just the mecca of sustainability, right? And then you move even to the best universities in the world and you see people printing more than they should, and using water and leaving the tap open while they brush their teeth and the fridge open while they're talk on the phone with their friends. And in this there was this little bit of a bug that became larger and larger and made me think, okay, space is really cool. There's lots of people working on space stuff. I feel that I might want to focus more on preserving the planet. And so decided to get my PhD in mechanical engineering instead in the field of passive design. And that's how I'm here. I became a building specialist, a building scientist.
I love this story. I absolutely love this story. All right, LA, I wanted you back on the show to talk about TEDI. The acronym is on a lot of people's minds right now. So let's start at a really high level and then we'll drill down a little bit.
Yes.
What does TEDI stand for?
TEDI stands for Thermal Energy Demand Intensity, TEDI. And what it means is how much energy demand you have either for heating or cooling in a building. So let's think about a space, hypothetical box that you want to keep at a particular set point. Let's say 72 Fahrenheit. You want to keep it at that set point, and you put this box in you know, in the outdoors, and so half of the year that box will need heating, and half of the year the box will need cooling to remain at a particular set point. The TEDI counts basically over in an annual basis how many watts do I need to put into that box in the wintertime to keep it at a set point at a particular set point. And then how many watts do I need to remove? That's the cooling TEDI to keep it at the same set point. And so watts put in is heating, watts removed is cooling. If you integrate that over a year and then divide it by area, you get TEDI. The units, interestingly, are the same units as energy. So in IP, it would be kBTUs per square foot per year. And so anyone who's used to EUI will notice that TEDI and EUI have the same units, but they are actually different concepts, if that makes sense. So a heating TEDI and heating energy are different.
EUI stands for?
EUI, thank you so much. Energy
Okay.
use intensity. And
Okay.
so many people tend to, many of us will count how much energy a building consumes in terms of EUI, so energy use intensity. And SI would be kilowatt hours per square meter per year. And so the units for TEDI are the same, but they are not the same concept, if that makes sense.
Okay. Can you give us a
Yeah.
little summary on why they're not the same?
Yes, perfect. So, for instance, let's go back to our cooler, right? To our box that we've put in the outdoors and we need to remove or put energy to. How we remove that heat and how we add that heat impacts how much energy we use. So, if you are heating a building or your box with, say, a bonfire, right? Or candles or a very sophisticated heating system, a heat pump, the energy you need to warm up the space to keep that space at a particular temperature would change, right? And so let's think of, say, a school. If you have a school that has a certain heating demand, if you decide to heat it up with the most inefficient system, let's say a gas furnace or something like that, gas boiler, or you decide to use a heat pump of some kind, their efficiencies are different. And what that means is that of the original energy source, be it electricity or gas, the units of energy you need to put into that system, the heat will be different, right? If you use a very efficient system than if you use a very inefficient system. However, the TEDI doesn't change. The TEDI is the same. And so we're just talking about demand. How you meet that demand is refers more to energy than to demand itself, right? And so on the cooling side, for instance, let's assume you have a building that gets really hot in the summer, and so you need to remove that heat. You could choose to open windows to cool it, which uses zero energy, right? And so the cooling energy would be zero, but your cooling demand is still there. You still need to remove those watts. You're just removing them with zero energy. Or you could use a very inefficient air conditioning system, which will use a lot of electricity, right? And so energy, the EUI will measure how much you need to pay in terms of energy, let's put it that way, right? Whereas the demand is just the demand, if that makes sense. And so again, the building that's heated up by candles or by a very efficient ground source heat pump has the same heating TEDI, but has a very different heating energy.
So TEDdy is more about, the actual design of the building rather than the mechanicals. It's about the envelope, it's about the roof.
That's correct. Yes. And
Okay.
so TEDI depends. It depends a little bit on the mechanical as well, but it should almost not. And so it's really focused on the passive aspects of the building design. And so envelope orientation, what can you do to the building itself to minimize its demand? Now, it also depends on, say, occupancy, right? And so if you have lots of occupants, that means that you're going to need a lot of ventilation, right? If you need a lot of ventilation, that air needs to be conditioned, either heated or cooled or dehumidified, right? And all of those factors play into the TEDI because in the end, heating air or cooling air to dehumidify it means adding watts or removing watts, right? And so the ventilation air, it's not only the heat that is lost or gained through walls and windows, but it's also the heat that is gained or lost through air coming into the building mechanically. So there's a little bit of mechanical that goes in, so you want to be very efficient mechanically, but in principle, it's based on most passive principles. And so, Passive House, for instance, uses TEDI as one of its metrics to quantify, well, how good is a building, for instance.
Okay. All right. Now I get it. All right. Now I want to talk about how you would actually go about doing a TEDdy calculation. Walk us through that and feel
Mhm.
free to go deep down that rabbit hole if
Mhm.
you'd like. As
Yeah.
deep
And
as you
so
feel
let's start.
comfortable.
No worries. Let's start high level. Let's think about our box again, right?
Okay.
And so our box will have, and I'm going to put myself in a heating situation. And so our box will have heat losses, right? And it's an occupied box. So it has people inside, it has lights, equipment. So it has certain heat gains, but it also loses heat through the walls. And so, again, in order to keep it at a set point of, say, 72, we need to put heat in to keep it comfortable, right? Depending on that balance of gains and losses. And so, what one does. And so, if we only had a single box, it would be very simple to calculate for every hour of the year. So, 8,760 hours, you're going to measure how many watts do I need to put into that space. Remember as well, that box, if it's a building, needs to be ventilated. And so, we're also counting how much energy is going into heating the air that needs to be heated up for ventilation, right? That energy will change whether you had heat recovery or not, right? And so if you have heat recovery, you need far fewer watts to heat that air that you're ventilating than if you were just opening a window and just having to heat up that air without any energy recovery. And so how does one calculate it? You count for every single hour of the year for a box. How many watts do I need to put in? You add them all up. It's watt hours really. You add them all up, and then you divide by the square footage of your building, and that is how you get TEDI. If we are talking about more than a box and we're talking about a building with many zones, then you need an energy model. And so your energy model, a standard energy model should be able to give you a TEDI number that basically just tells you this is what the demand for the bill for the building is. And so an energy model would quantify for every single zone and for every single air handler how many watts did I need to put in the heat, and then how many watts did I need to remove to cool, and it will give you that number for the overall building.
Okay. Now, I want to ask the question from the perspective of the owner of the
Yeah.
building. Let's say, for whatever reason, they need to do a TEDI analysis on an
Mhm.
existing building.
Yeah.
What do they have to do to prepare for that? What information should they gather? And just thinking about in terms of they're about to go into it, what should they
Mhm.
do to make sure that it works efficiently?
Yes, and so let's talk about still big picture, Teddy. We can then get a little bit more specific on the crooks and nooks and crannies of modeling, but the Teddy comes out of an energy model. And so if you have an energy model in principle, you should be able to obtain the Teddy. So I think maybe we should step back for a second and ask ourselves, why would an owner want a Teddy to begin with? Right?
Good question.
The Teddy is a useful ish metric. It's one metric that tells you how efficient your building is, but it's not necessarily the only metric that you should be looking at. And so owners care a lot about how much they're going to use, how much they're going to pay for utilities. And that is given to you by an energy model through energy use, right? And so Teddy doesn't really reflect nor the emissions of the building, nor the utility costs of the building, nor the energy use of the building. TEDI is a very unique metric that is typically used to show compliance, either with a local code or with if you're going for passive house certification. TEDI is one of the metrics that will be used to ensure that your building is meeting the standard. And so an owner should I can't think of a situation where an owner would want to know the TEDI just out of curiosity. It's not
Okay.
a very useful metric unless it falls within a compliance system, whether certification or code compliance, which Toronto has a TEDI requirement, Massachusetts has a TEDI requirement. That's really where I'm the expert on Massachusetts, and that's why it's being talked about a fair amount, is because Massachusetts implemented it in the new stretch code last year. But also, if the project is going after passive house certification, then a TEDI metric will be needed. Typically, the owner will need a consultant to interpret the TEDI results for them. Again, TEDI is a bit of an obscure metric that needs to be tied to other metrics to make sense to an owner.
Okay, yeah, let's talk about that a little more then.
Mhm.
So, let's first the
Yeah.
process of calculating the TEDI. I'm assuming that must reveal some good information, useful information in terms of if you want better, energy efficiency, if you want to reduce your energy consumption, here's a list of things that you can do. Does that fall out of that kind of information fall out of the analysis?
Kind of. I would say that energy use is probably the best metric to do that. TEDI can be very misleading because your cooling TEDI could be really high, but if you're using natural ventilation, you're using zero energy to deal with that cooling
Ah.
TEDI. And so, from an environmental standpoint, that cooling TEDI is not that relevant, right? And so it's really how the key question, just from an environmental standpoint, from a climate change standpoint, from an emission standpoint, is the connection between TEDI and energy use. It's the efficiency. In order to calculate energy use, basically, you take your TEDI, you divide it by your cooling efficiency, and you get your cooling energy. And so, really, how many electrons do I need to actually cool that building is what the planet cares about, is what owners care about because they'll have to pay for that. And so TEDI is a useful metric to understand passive design, how successful a building is passively. But I would say that EUI is perhaps a much more tangible and actionable metric, or metric that one can act upon, as opposed to TEDI. So yes, I know I'm giving the impression that TEDI is not very useful as a metric. It really isn't without the context of a certification or a comparing apples to apples, where it becomes really useful. And this is where the modeling the TEDI becomes at the forefront, comes to the forefront of us. Where
When
TEDI becomes really useful is when we are trying to compare buildings apples to apples. It's a metric that has been used to compare the performance of many buildings to one another. So let's think about the miles per gallon metric for cars. When you value for Windows, NFRC, right? There are certain metrics that are very helpful to just understand how does one thing compare to the other. Even though we all know that once I buy that car, the car will not be consuming what they told me in that label, right? TEDI has become one of those metrics that is a little bit like the miles per gallon. It is a metric that makes it easy to understand how well is your building performing passively, right? How well designed from a passive standpoint is your building compared to others, regardless of how who's occupying it or how is it being used. And so very similar to miles per gallon for a car. And so with a car, you might get a, Hummer or a Prius or anything in between, and you'll get different miles per gallon. Most of us will choose the car that we want to buy based on many metrics, but that is one of the metrics we want to look at, knowing 100% that if I live in a rocky mountainous area, I'm probably going to be consuming much more gas or electricity than someone who lives in the city and only drives in a flat terrain 3 times a day, right? Or 3 times a month. TEDI has been used as one of those metrics. And so Passive House, for instance, uses TEDI. Passive House is a certification that focuses on comparing apples to apples. And so you will not necessarily enter in your energy model, you will not necessarily be modeling the actual occupancy of your building, but you will be given, if this is a residential building, you should be modeling it with a particular occupancy, a particular schedule, particular loads, particular everything. And then you compare this building to the other. TEDI is very similar for Massachusetts, for instance, where in Massachusetts, in order to meet the TEDI thresholds, and so in Massachusetts, projects are given a maximum heating TEDI and a maximum cooling TEDI that they cannot exceed, very similar to Passive House. In order to calculate our TEDI, we need to use the occupancy and the loads and the ventilation that are given to us that aren't necessarily representative of what the building will actually use. And we will obtain this number that represents how the building was designed, but not necessarily how the building will be used. The last thing I'll say about this is, and we can elaborate on any of this, has lots to dig into, lots of information to dig into, but the how the TEDI is measured for Passive House. So the methodology, the protocol to calculate the TEDI for Passive House is very different than the protocol to calculate the TEDI for, say, Massachusetts stretch code. And so the same building will have a different Passive House TEDI than it will have a Massachusetts TEDI, if that makes sense. It's as if in Japan, the way miles per gallon were calculated were just a different protocol, right? They just test the cars in a different way. And so the numbers are different. They're not apples to how someone in the US would calculate miles per gallon. And so TEDI itself is a concept, but the definition of the thresholds and how we meet it is based on a particular framework or protocol for modeling.
Okay, so right, so that leads me to I'm getting the impression that in isolation, Teddy could actually be could be negative. If you were just focusing on Teddy, you could create a building that's not necessarily optimized. And the example that comes to mind, you already spoke of natural ventilation,
Mhm.
because it would, penalize natural ventilation, right? And would it be the same for windows, for example, for natural light and views? I know Passive House takes it very seriously.
Mhm.
They want natural light and
Right.
views. But I mean, if you purely engineering perspective, if I wanted to optimize, get the best Teddy, I'd build a box. I'd build a dark box with no windows, no no doors.
So,
It would
not necessarily. So
okay.
here's what's different when you are designing for Teddy. So Teddy, your first statement, I fully agree with that. If you only take Teddy as the metric, you could end up with a really inefficient building from an energy standpoint, right? From a
Mhm.
pollution standpoint, which is what we care about, from an emission standpoint. What's different is that a building that is very inefficiently cooled with the worst AC, your mom's AC that has been stored in the basement for I don't know how long, you take it out, it is the most inefficient thing. That will consume much more energy than if you just opened windows, right? And yet the Teddy for both will be the same. And so, in a way, yes, you are not getting credit for how you meet that demand in any way by using Teddy. And so, Teddy should never be used on its own, which is one of the criticisms that have come up with the Massachusetts stretch code is that Teddy is the only metric that you need to meet. There is no energy use threshold, also. And so that's a very
Right.
slippery slope that one could fall on, and that we have been talking to the state of Massachusetts a fair amount about. So, if we look at daylighting and everything else, yes, that is not accounted for, but it isn't accounted for. Solar gains are part of the Teddy. So when we're talking about daylighting, having windows will impact your Teddy in two ways, right? And so Teddy is daylight independent, right? So Teddy does not care if your building is properly daylit or not. The same way energy use intensity doesn't necessarily care that much, right? But it does care in terms of how much heat you gain through windows in the wintertime, right? And so if your windows are reducing your actual demand from a mechanical system, then the Teddy is definitely helping you, right? Now, windows also will leak heat at night, right? And so that will increase your heating Teddy. And so you need to strike a good balance of, as we do with energy, the right amount of windows so that you get the right heating, but don't lose too much heat at night, right? So you get good heat during the day, but you don't lose too much heat at night, right? And so amount of windows matters for Teddy a fair amount. It also matters for cooling, right? Because the more windows you have, the more you need to cool, and your cooling Teddy is going to be off the roof. So in principle, Teddy follows somewhat the same principles as an energy accounting tool, like an energy model that will count energy use. So Teddy will be impacted in the same way by amount of windows as your energy use would, in a way. More windows will tend to lead to an excessive use of energy because you need to heat more, you need to cool more. No windows whatsoever, might be okay from a Teddy standpoint, but are probably not ideal either because you kind of need to lose some heat in the summertime and gain some heat in the wintertime. So this is a place where the sweet spot for Teddy tends to align with a sweet spot for energy, which is also quite in alignment with daylighting, in that you really don't need more than 30% of window to wall ratio to have an adequately daylit building that also has low energy use and also has an optimal Teddy.
Right. Okay. So it does seem to have somewhat of an opposing position to a human-centric design, but you do believe there is potential to balance all that out to get,
Yeah, I would not say. In
fo-
fact, I would say they're very much aligned, and that Teddy will is really about quantifying how well a building is designed passively. And so I would say
right.
Teddy will definitely push you in the direction of finding the best orientation, locating the windows in the right places. It's a reason why Passive House uses it as a metric. So definitely, I would not advocate for 80% glass, even if there
Right.
is, we all know that doesn't bring more light in. It just brings worse light in, right? And so I think that it is well aligned.
Transparent glass, yes.
Transparent glass.
Yes,
Yes, yes,
yeah.
yes. The, it is aligned in that sense. We do not want, if we're going to use non-transparent glass, it still needs to perform like, as well as a solid wall, right? It needs to perform. It needs to have a good, R20, performance in order to be good. And so I would say that it is very much aligned with human centric design. It leads to more comfortable, the fact that there is less glass, then, the spaces are more comfortable. We need to use fewer, perimeter heating systems, et cetera, et cetera. So I would say TEDI is aligned with human centric design.
Gotcha. Okay. With sort of more traditional materials for sure. Okay, let's talk about architects, builders, stakeholders. Is there anything else that they should know about Teddy that in your daily experiences
Mhm.
they typically don't? Like just sort of
Yeah.
prepare them for the fact that, it's going
Mhm.
to be necessary in certain areas. What else
Yeah.
would you share?
I would say from an owner standpoint, it depends on how they interact with Teddy. If they are interacting with Teddy through the lens of passive house is a very holistic framework that is looking at many things. And so talking to the architect and the passive house consultant and making sure that you're, optimizing the passiveness of the building is the most important. And Teddy will simply just be one more metric. And it comes as the package of what you use to certify for passive house, right? And so it's something that you should know it exists. You could ask questions about it. It's one of the many metrics that are used to determine whether a building complies with passive house requirements. If an owner is encountering Teddy through the state of Massachusetts, we know New York is looking into that. And so there are many states that are looking at Massachusetts as an example. And so if they're looking at it from a code compliance standpoint, what needs to be known, and so this is, I'm going to be very Massachusetts centric for just a second,
Sure.
is that there is, in order to comply with Massachusetts code, you need a different model. It's a different energy. The protocol is so different to measure TEDI than the protocol you would use to just predict the energy use of your building. That you need two separate energy models and you need to pay for two separate energy models to measure TEDI and to measure EUI or energy use intensity. What that means is that and again, remember the TEDI model is a little bit like a miles per gallon model. It doesn't really predict how much you're going to actually use in terms of energy, right? And so what happens is that we might find ourselves tweaking the TEDI model, optimizing the design to meet the TEDI thresholds, right? To be below the heating TEDI and below the cooling TEDI, right? But if we're not looking at the proposed energy model or the model that actually predicts energy, you might find yourself reducing the demand but increasing the energy use.
Right.
Uh, for instance, if you are very much focused on reducing the heating TEDI, you could say, well, I'll put R60 in the walls, right?
Yeah.
R80. And that will certainly help you reduce your heating TEDI. That will not help you with your energy. There is a point where if your cooler is too thick, you're going to start using more energy for cooling. And so, from an owner standpoint, you need to know that there are two models, that one of them is a pass or fail, which is the TEDI in Massachusetts. And the other one is the actual energy use, is what you should be designing your building to. And so you need to have both and run both and work with someone who really understands the TEDI protocol and understands how it impacts the actual energy modeling to have a more successful design. The other thing that they should know is that until very recently, and then again, this is very Massachusetts based, but until very recently, the code compliance model would be run in CDs and construction documents, right? It's like, let's just make sure we're complying with code was easy enough that we were working with the model, the EUI model, so your proposed model, the model that replicates your building very well. You're working with that one from the beginning, but you're really not checking whether you're meeting code until the very end, because meeting code, if you were designing a good building, you knew you were going to meet code. These days, you don't really know if you're meeting code from day one. Meeting code and meeting the TEDI thresholds is really hard. And what that means is that you do not want to get to CDs without having checked whether your building actually meets the TEDIs, because that could mean that you had to mass your building completely different, that you had to orient it completely
Uh,
different. Right? There are many early design decisions that will impact TEDI that didn't impact other code compliance metrics as much before. And so they will need to pay for the TEDI model and they will need to run. We strongly recommend them running a TEDI model from as early as the first schematic design set is out to make sure that you're on the right path. You may need to change the way you provide air. So your ventilation, TEDI is highly dependent on ventilation. And so if you are not meeting the TEDI, you might need to change your ventilation, how you're ventilating. And so for instance, if you were designing a school that did not have demand control ventilation, you may need to incorporate that. Demand control ventilation is when you only provide ventilation based on CO2 levels, as opposed to just dumping, assuming that there's a certain occupancy and providing more fresh air. And so you may need to change your mechanical system. We've had projects who have had to halfway through design change the mechanical system they're using.
Right.
How much heat recovery you're providing. You should be providing as much heat recovery as possible in your systems, but you might realize that you're not providing enough. And so you'd rather find that out in schematic design than find it in CDs. I'll say the last thing is that the protocol to model TEDI, and again, I apologize for being so Massachusetts centric, but I feel that other states are going to mimic what Massachusetts is doing. The protocol to model TEDI is not straightforward, is not easy, which means that we have seen the learning curve for modelers has been really steep. And in our company, we have worked on many projects where we might be the second or the third modeler to come in to remodel the building because they weren't passing before because the protocol wasn't followed. There are many loopholes with the protocol. The protocol isn't fully documented, et cetera, et cetera. So it takes all this to say it takes an experienced modeler to model the TEDI accurately for Massachusetts. And so if anything, if you are an owner in Massachusetts, find a modeler who has done, 5, 6, 7, 10 TEDI models before yours. If this is their first TEDI model, it might take a lot of effort. It took us about a year and a half to nail our first TEDI model. In a project, sometimes you don't have enough time for that. It took us a year and a half on one single project to actually get the TEDI model right, our first TEDI model.
Okay. All right. Interesting. So it should take place at schematics, right?
Yes.
That's the importance. Okay, yeah, okay. I
Yes.
really wanted to emphasize that for sure.
Mhm.
Yeah, absolutely fascinating. Do you see the stretch goals that are happening in Massachusetts, including the TEDI model? How much are you hearing about other states adopting that protocol?
Heard a
Or
little bit about other states. The
I
main
think
reason for
Ohio
this,
is Ohio there now,
I don't
or
know. I don't know. I
okay,
don't think anyone has adopted it yet. I do know that
okay,
New York is looking at it seriously. And maybe we should talk a little bit more about why Massachusetts implemented the TEDI.
sure, yeah,
Um, because it's counterproductive. It's confusing for people to say, well, if the TEDI isn't representative of how much energy my building will consume, or it doesn't care as to whether I install a very poor cooling system or a very good cooling system, then why are we even doing this if what we care about is emissions, right? And so, what we care about from a climate change standpoint is emissions. However, states are dealing with a significant increase of electrification in buildings, which is a good thing, right? So, we're phasing away from fossil fuels and moving into all electric buildings. We're seeing more and more all electric buildings in around the country and around the world. What that means is that what used to be manage the demand. Again, we're talking about heating and cooling demand, right? Until very recently, the cooling demand managed by the electric grid, and the heating demand was managed by the gas grid, right? And so you had the gas grid or whatever, fossil fuel based heating you used was sized for the heating demand of all buildings in Massachusetts or in New York or in Illinois, right? And then the peak demand for for the electric grid was based on the peak, which is cooling, which is the summer season, right? When cooling is happening. What happens? Now we're saying buildings are all electric. So you electric grid are now taking care of not only heating, not only cooling, but also heating. And so now your peaks are no longer happening in the summer, they're happening in the winter. And guess what? If a building is very inefficiently designed, your peak heating is going to far exceed your cooling load and you will not be able to handle the demand. And so it has to do with grids and how much can we, within the capacity we have, can we um, support all the buildings that are shifting to all electric. And so, as the next step, what Massachusetts has done is said, okay, well, we have two choices. One of them is we triple our energy generation power, right?
Right.
Which is extremely, insanely expensive. Or we promote for the same types of buildings. And so we keep building business as usual, right? Or we promote building design practices that ensure that for as long as the building will be around, its envelope, its bones are solid and passive, right? And so if we can cut down the demand, the heating demand for a building by a third because it is really well designed, then I don't care that much about the mechanical system because the building's actually really well designed, right?
Right.
And mechanical systems will get more and more efficient. And so, in that sense, we are seeing more and more states interested in the Massachusetts model because it's focused on the resilience of the grid. And then as a byproduct, it reduces, emissions because a very well designed building will naturally consume less energy, right? And so they're mostly focused on the demand, not the energy use, but they're both important.
I am so glad you explained that because I have to admit I wasn't quite getting it, but now I
Hmm.
do. Thank you for that. That was time well spent for sure. Okay, we're getting close to the end, LA. I know I've asked you this question before, but let's see if it changes very much. What makes a great building?
What makes a great building? A
Yeah,
great building is a building where people are happy, are productive, feel natural in their environment, feel comfortable with their environment, feel connected to the outdoors, and where that building does not consume that much energy, also, right? And so it's a building that is in line with the environment itself, but that also makes, productive occupants. If occupants are not happy, they're not going to use the building well, and, it will all be effort wasted. And so, happy occupants make happy buildings and make a happy planet.
that is a brilliant answer. Thank you for that. Before we finish up, is there anything that you'd like to share in terms of what you're working on these days or any special announcements? Anything that you'd like to promote?
Yes, so we are working. So anyone working on struggling with the energy code in Massachusetts, we are doing lots of work for that. And so definitely give AIRLIT a call if you want to learn more. We do training, we do modeling, we do everything and anything in between. We are also going on, I mentioned natural ventilation a couple of times, and we've talked about this in the past. But, we're working on a couple of really cool naturally ventilated projects, which is my background. So my PhD was on natural ventilation. So we do natural ventilation consulting. And so very excited. If anyone's looking for, a thoughtful consultant, that's us. That's my announcement.
That is definitely you. Thank you so much. I'm so glad you came back and did this. That was a really important conversation.
Thrilled to be back. And if anyone has any questions, there are so many questions around TEDI. Feel free to shoot me an email or a message on LinkedIn, and I will be happy to answer them.
Sounds good. LA, thank you so much. You take care.
Thank you. You too.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.